Hi, my name is Ed Ho, and it's a real pleasure and a privilege to be here with our speakers and you, our audience. I thank you very much for joining us today. The name of this session is Clean, Green, and Affordable, Solving the Energy Challenge. Now, I'm going to introduce all of our guests. We have an excellent panel. We have Douglas Wicks, who is the Program Director with Advanced Research Projects Agency Energy, which is ARPA-E and part of the Department of Energy. And he will give us an overview of advances in high potential, high impact energy technology research projects in their program and a general overview of what they're doing at the Department of Energy. And his project specifically that he's working on is funding development of geological hydrogen. We also have Fionna Millikan, who is the head of development at Green Gravity, whose company is redeveloping mine sites into energy storage hubs in Australia and beyond. We also have Jos Diening from Global First Power, the president and CEO, and they are developing a nuclear microreactor in Chalk River, Ontario, and I would say will likely be the first one in Canada. Also, we have Kirsten Marcia, who is the president and CEO of Deep Earth Energy Production, who is a leader in Canadian geothermal energy production, and they're working on their first project in Saskatchewan, which is again, industry leading in Canada, certainly. And my name is Ed Ho. I will be the moderator. I am an energy transition consultant dealing in generally policy and finance with energy. And our goals today are really to inspire you to consider opportunities in the energy transition or climate or sustainable development or the road to net zero, however you want to frame it. There are so many opportunities in so many vast fields in what we're doing and everyone's working in. And certainly there are opportunities in science and engineering, but there are jobs and opportunities in other things like policy, in communications, in accounting, in economics, in graphic design, you name it. And there are also many, many opportunities that are and will be available in trades that will need to be part of the build that we will be building for the next decades in mining, as electricians, in pipe fitting, construction, and the like. So there are no shortages of opportunities in what we're doing. I'm going to give you a personal introduction to our topic of the day, mostly because I think the interesting point when speaking to everybody was that I think none of us in the group today thought that we would be where we are today when we were younger. Myself, I grew up in Northern Ontario. I grew up in Sudbury. And when I was 17, I went to university and I was taking I was in chemistry, hoping to get into medical school. After realizing I would not achieve the marks I needed in chemistry to get into medical school, I opted to change programs after my degree finished and went into French literature, of all things, because I was a language buff as well. And I finished that degree as well and was accepted to a master's in modern French literature at Queen's. That same year, my mom had passed away, so I decided to take a year off where I spent a year with my wife while she finished her law school, and I took the Canadian Securities course, which is the accreditation you need to basically get into financial services in Canada. And after I finished that course in that year, I went back with her to Toronto and never pursued my master's otherwise. And I got an entry-level job in a mutual fund company through sales and marketing into a point where I realized I wanted to go into fund management and become a portfolio manager. So I did my chartered financial analyst designation, which is another 3-year program. After about 10 years in that field, I left to open a restaurant. And then I was in the restaurant business for 14 years and I worked on 5 different projects, and we closed the final of all the restaurants just 3 months before COVID hit. So just in the end of 2019. And at the beginning of COVID, I did some soul searching and I worked with a coach and I tried to figure out, as I'm pivoting my career, what to do next. I could go back into finance and do something relating to that. But then I realized in building, a vision board and my dream board, which is still beside me on my back of my door, about what are my skills, what are my dreams, what are my aspirations, and what am I good at in life. And I've realized over my lifetime in everything that I did have a lot of points that in common with respect to energy and climate related issues. So to enhance my finance degree, I actually went back to school again at about 50 years old to pursue a master's in energy policy and climate. So that's a long story, but I just wanted to sort of relate to you that I had no idea what I was doing when I was 17 years old, where I was going and what my career would take me. And I would even say, even at this point in my life, there are lots of opportunities that I'm still pursuing, and I haven't quite made up my mind which direction that's going to be. And I'm not advocating that maybe this is the way you should pursue your life, but that everybody in the group today has had somewhat of a similar journey in the sense that they didn't know where they were starting or where they would end up as we're sitting here today. So as it stands right now, yeah, I am an energy transition consultant, and I would advocate to anybody, if you want to just say, hey, I don't have a job, but if you call yourself a consultant, you feel like you actually have a job and you can actually know something about something. So it's a valid way to go also if you want to take a career path by working for yourself. So anyways, in my program, one of the things I loved about my program in energy policy and climate was that we were encouraged to pursue whatever path we wanted. It was a fairly technology and policy agnostic program, but for the general climate goals of CO2 mitigation, adaptation, and they even advocated geoengineering if you wanted to. What I found was surprising, we were given this book in our climate science course called What We Know About Climate Change by Carrie Emanuel. And if anybody wants it, I can send you a copy because it's available online. But it's a 70-page book, which seems a little bit small for everything we need to know about climate change. The simplicity of it really does give us a good platform to begin a conversation with anybody who really wants to address any of the problems to do with or challenges to do with climate change. I'm going to show you one slide to get us back on track as far as our topic of the day goes. Where are we here? And it'll be basically our CO2 emissions, and it's from the US. And the slide, it comes from the US EPA, but what it really shows you is that there are many different sources of carbon emissions, and it's not just coming from power generation as I think a lot of people perceive it. And by getting rid of the coal plants and getting rid of the gas plants, we're not going to solve the entire solution in our emissions. It's only 25% of the problem in the US. And it really depends where you are. In Canada, it's only about 2% of the problem is in power generation, because we have an awful lot of hydro and nuclear in Canada already. And then people will say, well, if we electrify our vehicles, look, transportation is 28%, but that only accounts for vehicles. And there's also global shipping as far as long distance, trucking and freight on ships as well, that is not going to be solved by the electrification of vehicles. So I just wanted to point out to everybody in the audience that there are lots of challenging issues in carbon in CO2 reductions, and especially in industries such as cement making and steel making. There are incredibly more challenges than just electrification in general. So now everybody in the group is going to do an introduction of who they are and what they're doing, and I will come back after their introductions and have a few questions for everybody. So I'm going to start with Doug, who is going to address some big picture parts of what he's doing in his organization and as the specifics of his project as well.
Thank you, Ed. Yeah, so Doug Wicks here. I worked for the Advanced Research Projects Agency of the Department of Energy in the United States. And it's an interesting program or interesting group that was started about 15 years ago to say, how do we address the environmental, social, and economic challenges of the energy transition? So this was an activity that was viewed as pivotal, that we need to find transformative technologies that are outside of the normal research areas, to really catalyze this change to address the energy challenge. And I want to emphasize to everyone, the energy transition is probably the largest challenge ever facing mankind. And it's quite impressive to look at the numbers that we have to do. And within the within this group ARPA-E, there's 20 program directors such as myself that are funding research in all topics, whether it's fusion energy, nuclear energy, solar, ocean energy, housing efficiency, and the likes. And it's an amazing place to work. And I'll come back to some comments, kind of echo some of the stuff that Ed said about where we end up. But within this organization, the area that I look at is how do we look at using the Earth's resources to solve the energy transition? So quite specifically, if we look at the energy transition, we're going from a time of what's called big oil to a time that's called big shovels. The energy transition is going to be based on mining. And it's an area that I'm quite excited about, as we have to increase our level of mining by, almost an order of magnitude to address the energy transition. Everything we want to do is based on minerals, whether it's renewable energy, transmission, batteries, that all starts in the earth. And the question again comes back to, how do we do this in such a way that we do not destroy the environment, we do not disrupt society, and we do not have huge economic costs? And it's quite an interesting challenge. And I will say there's surprising things still to be found. I mean, if we look at this in the earth, there is amazing stuff that's taking place beneath our feet that if we understand and someone can come up with really smart ideas, they can be quite incredible. And what I would like to share is kind of real quickly something I did last week. And pardon me as I do this. I'm going to shift over. We'll see if I can get this all to work properly. And I'm going to show a quick video, and hopefully this comes through. And this is a video I took in Oman last week on the Arabian Peninsula. And hopefully it's going to work for me. It worked just a minute ago. But what you're seeing behind this spinning wheel is actually someone bending over a spring within a wadi in Oman. And coming out of the ground is literally pure hydrogen. Just a second here. I really want to show this. And it's not going to load on me. I have to apologize, everyone. It turns out that the Earth is generating pure hydrogen that we can harvest for energy. Everyone has talked about the challenges of where we're going to get the energy transmission from, but it turns out the Earth is generating material that we can use directly, coming out of the ground. I apologize for that slide. And this was unknown a few years ago, which I think it's important for young people to realize that there's so much yet. Okay, I think I'm back again. Hello?
We can see you, Doug. Please proceed.
Okay, sorry about that. The video, I think, kicked me off of my connection. But there are so many challenges to be met, to do this energy transition. It's a fun time to be in the space of saying, how do we do energy really to save your generation? My generation, the boomers, we caused the problem. And hopefully we leave you some hints on how to solve the problem. Kind of coming back to what Ed said, about where I would be. I never imagined myself when I was 18 working with the smartest people in the world. I mean, I have the pleasure to really work with some amazing, amazing people who hopefully can solve this energy transition. And as I was telling Ed as we went through this, I had to go through a process of learning. I flunked out of college twice. That if you take a look at it, I'm probably the only person who's been a chairman of a major academic program who had flunked out of college twice and needed to grow up and figure out how to do it. I'm now in probably the 7th phase of my career, going forward. And I'm still trying to figure out what I want to be when I grow up. And so I would encourage everyone listening just to remember, it's never too late to change. It's never too late to go off and reinvent yourself to go forward. If some dumb kid from North Dakota in the United States can end up in DC as leading massive challenges, you guys who are a lot smarter than I am can really have a huge impact. With that, I'll turn it over to Ed.
That's great. Thanks, Doug. I don't think you're as dumb as you think you are. But we're going to move to Fionna next to talk about...
I was dumb.
Then you've come a long way to talk about storage. Go ahead.
Fantastic. Lovely to meet you all. I'm assuming everyone can hear me. So Fionna Millikan, I'm the head of business development at a company called Green Gravity. And I'll jump into that in just a sec, but just by way of a little bit of background. So I've got an engineering and arts sort of humanities degree, and have also followed one of these paths that's probably a little bit unconventional. So I completed my degree and then went straight into management consulting. So as Ed said, if you want to call yourself something important, call yourself a consultant. And I did that on and off with sort of a few sort of senior leader roles in there as well for kind of 25 years. My client predominantly, I worked through a range of industries, but I spent a lot of time working for BHP. And that's probably how it's kind of led me to this transition. But probably just reiterating, what Doug said as well, you never know where the dots connect. You don't know how all of these threads lead you to where you are. But my kind of tenuous journey through many different sort of industries and businesses and different parts of BHP has now led me to being part of this energy storage startup that is Green Gravity. So I'm going to just share a couple of slides. So let me just bring this up. All right, so I'm assuming that everyone can see this. So Green Gravity is, here we go. We are an energy storage startup that is basically generating gravitational energy from disused mining assets. So we're using mine shafts to create gravitational energy. So we store the energy effectively on the surface of the shaft, and then as we lower weights down, we're actually generating energy. In terms of how our system works, it's really a battery. So if you think about a battery where you charge the system, you store the energy, and then you discharge the system, what we're actually doing is using the mine shaft effectively, so a vertical mine shaft, as part of this system. So we charge the system by lifting a heavy weight to the top of the surface of the shaft. when there's an abundance of solar, call it. So think about the middle of the day when effectively solar energy is largely free. You lift the heavy weight to the top of the surface with a regenerative motor that acts as a motor while it's lifting. You store the heavy weights on the surface, and then when you need to use the energy, you lower the heavy weights back down the mine shaft, turning the motor as a generator, and you put the energy back into the grid or back into a closed loop circuit if that's needed, say at an operating mine. So that's effectively our system in a nutshell. In terms of what it actually looks like, so we're reusing mining assets. And we get many questions saying, well, how scalable is that? What does that actually look like? In Australia alone, we actually have 95,000 mines, of which there are 85,000 inactive mines. So that is an enormous number. Not all of those will be suitable for our technology as we're looking at it right now, but we are also looking at an open cut version of the system too. In the US, there are 500,000 inactive metal mines. So there is an enormous potential here, and globally the estimates are sitting at well over 1 million. So it's a very scalable system, and we don't need them all to work. In Australia alone, from 180 locations, we've identified 13 gigawatt hours of potential, and globally from 4,000 locations, we've identified 285 gigawatt hours of potential. So it's actually enormously scalable technology. It's long duration storage, which is what we need to really support the back end of this energy transition. As we start to rely more on renewables, we need to be able to store the energy so we can dispatch it and use it when we need it. We're reusing assets, so we're actually keeping the costs down by leveraging the infrastructure that's already there, whether that be the shaft or some of the equipment that's actually on some of these transitioning mines or legacy mines. And one of the other features of our technology that's quite unique is that we're actually supporting the mining transition as we're actually repurposing assets. We're giving them an alternate economic use case. So in this situation, we actually need the infrastructure to be maintained, which has real benefits for the miners because they can actually not have to rehab and make those good to an end state that may be farming or native land. We actually require the infrastructure to be left in place. So that enables them to channel their dollars that they would have spent into rehab into other areas and actually making those sites good in other ways. So that's probably it in a nutshell. So let me just stop sharing. So that's effectively the green gravity system. So where we're at is we're still relatively early stages, but we've got a test facility up and running that's actually in Australia. So I'm based in Australia in Wollongong. That is actually being developed to code the control systems and work through all those parts before we actually get into a real mine shaft demo. Concurrently, we're actually building the whole system in the Omniverse. So we're actually working with NVIDIA, that many of you would have heard of, to actually build a digital twin of our system that enables us to scale rapidly into different locations, because every mine shaft and every location is different and bespoke. So we need to be able to learn quickly and scale and modify the system based on the different dynamics. So we're actually working through that with some very sophisticated partners that will enable us to grow our global footprint. Thank you. Over to you, Ed.
That's amazing, Fiona. And it's interesting. I think when most people think about storage, the first thing that comes to mind is battery storage or electrochemical storage, whereas your method of mechanical of storage, in fact, is the biggest source of storage right now is actually hydro. Pump hydro is the biggest batteries in the world right now, and you're following down a similar path, and the efficiencies in mechanical storage are quite great. Like, what kind of efficiencies are in your system?
Yeah, we're talking about 80%. So our round trip efficiency is actually probably more attractive in the context than even a pump hydro in this situation, because we're using the vertical height effectively. So we don't have the issues of friction that come into it. So it's sort of 80, 85% is what we're getting out of our testing.
That's amazing. And the little boy in me is getting all excited about the technology discussion. And we have Jos coming on next. And when I was in grade 7, I actually went to a field trip to Chalk River, where Jos's first project is, and where it's Canadian Nuclear Labs are. And I was introduced to CANDU Reactors, which is a Canadian, a very, very old and well-used Canadian technology. That's basically all 19 reactors in Canada are based on this. And Jos is going to talk about his project and being cutting edge on a new technology for nuclear.
Thanks, Ed. So really excited to be here today and be part of this panel. So my name is Jos Diening, President and CEO of Global First Power. And so we're a company that's focused on implementing and operating new nuclear technology, and specifically very, very small nuclear technology. We call them micro modular reactors, or MMR for short. And like Ed said, we are on track to build the first MMR in Canada and probably the world. So it's an exciting time for us. This new technology can have a huge impact when it comes to addressing climate change, as it provides reliable, low emission energy to communities that don't have many options to them now. And in Canada, I'm from Canada, based out of the Toronto area, we've got a lot of remote communities that rely currently on diesel to power their microgrids. And so these are the things that I'm really passionate about and why I'm part of this company. And the GFP team is the same. We're a group of young people who want our work to make a difference. We know this technology that we're implementing will do that. And we know that the impact can be big. There are many different applications for our units. And I spoke to remote communities. That is a really important one for us. And these communities don't have a lot of options, and those options aren't always reliable. And when you think of diesel, there's communities in Canada's north that can only bring in diesel when the ice roads are there. And so when the diesel runs out, they're flying in diesel on planes. So yeah, these communities don't have the same options or the reliability that we would be used to in more urban areas. And so energy equity is one way that this technology is really, really important. So our MMR can be used to decarbonize industrial activities, remote minings, big commercial operations like data centers. And so that's what we do at GFP, and we're really passionate about it. So let me see if I can just switch the slide. So a little bit on career path, and so how this is relevant to the folks on the call today. And when you think of nuclear energy, people think high tech, and really, a lot of the plants that are operated today were built in the 60s, 70s, 80s, or sorry, were designed in the 60s and 70s, built in the 80s and 90s. So it's actually pretty old technology, designed before computers were really a thing. And so what we have now is 40 years of operational experience, 40 years of development of the technology, and we can incorporate that into this new next generation of inherently safe reactors. And really, we need people like you on this call to help us. You're absolutely critical in solving these big issues that we're talking about. So it's great to see the passion from this next generation that are just getting started on the career path, whether it's, you're finishing school, you're starting your first job. Passion is definitely something that we need, and it's a core value of GFP. And you'll hear me talk a lot about it today. So some advice. I got some advice in my career really early on, and it was, don't run away from issues or challenges, run to them. And that's served me really well in my career, and it helped me to get to where I'm at. I know that being early on in a career, it can be scary, it can be intimidating. You're not really sure what to do or how you fit into the group. That was true for me when I started. But in my experience, I found that the best way to success is to get out of your comfort zones, take risks, and don't be afraid to fail. The people who do that, who get out of their comfort zones, are the ones that develop the fastest. And so not being afraid to fail is probably the best thing that you can do for your career. And I always got this saying that if you're not failing, you're not learning, or you're not pushing yourself hard enough. So I'm really looking forward to our discussion today, because I think that it's important for all of us to learn about different industries and figure out ways that we can collaborate and work together. And this event is a great way for you to learn knowledge and get an understanding of the potential that's out there for you. So I think that's enough for me, Ed, and back to you. Looking forward to the discussion.
And it's really exciting for you to talk about that. And we may not get a chance to touch on the issues of a just transition in our session, but the solution that you're talking about will help alleviate a lot of the challenges, not just with off-grid mining and other applications, but as you said, there are many communities that really don't have much infrastructure as far as power goes, and they're not on the grid, and to have to barge in or even fly in diesel fuel to power these communities is it's an environmental hardship. It's a physical hardship. And as a community to rely on that supply chain to get everything seems a little bit. It needs to be fixed, and there are lots of challenges in this transition that will be fixed by a lot of solutions. And looking at what you're doing is for me one of the greatest solutions, I think, for Northern Canada that we have. And moving to Kirsten now, and I just sort of had this realization that everybody's topic has something to do with the ground. Doug is pulling hydrogen out of the ground. Fiona's putting energy back into the ground. Jos is using uranium that comes from the ground. And Kirsten, you're almost even more direct, and you're pulling heat directly from the ground for creating electricity and other heat applications. So I'll let you go ahead and introduce your company as well.
Thank you so much, Ed. It's a pleasure to be here with the other panelists. It's a great opportunity to speak to emerging students in this industry. A little bit about myself. I'm a geologist. I've been working in the province of Saskatchewan in Canada as a geologist my entire career. I've worked right out of university. I was a well site geologist in the oil field. I worked in gold, base metals, even diamonds. Believe it or not, there are diamonds in Saskatchewan, and even coal. So I'm going to talk a little bit about our project, and I'll tell some stories too, hopefully along the way. So we're developing a geothermal power field in Saskatchewan. When you think of Saskatchewan, if you're familiar with it, there's no volcanoes, there's no big faults. In fact, if you're standing out in the prairie, the last thing you would think about is that there's a very hot 120-degree geothermal resource 3.5 kilometers below the ground. We're going to be drilling into this deep sedimentary sandstone, 3.5 kilometers down, and then a horizontal leg of another 3,000 meters, and pumping hot brine to the fluid, converting it to power, and selling it into the grid. It's globally unique. Obviously, geothermal is not globally unique. We have geothermal resources all around the world. In fact, the United States is the largest producer of geothermal power. I'm actually calling in today from Reno, Nevada, where they're hosting, where there's the big geothermal conference called the GRC, Geothermal Rising. So it's a kind of a good vibe here going as we celebrate our geothermal industry. But what's unique about this project is that it's a sedimentary geothermal. So in order to achieve that, we have to be able to produce fluids at enormous rates. And through the exploration and testing phases, we realized the only way that we could achieve the fluids at economic rates were to drill horizontally. We did that, it worked, and we found out by accident that this well design has never been attempted for geothermal in the world before. And so just by the geology dictating what type of well design that we need to have, we ended up with a very unique, innovative well design that is now deployable around the world in other sedimentary basins to crack the code on some of these lower enthalpy projects. I'm going to tell some stories about twists and turns along the way, but as an intro, that's our project, and excited to be speaking with you today. Thank you.
That's great. Thanks, Kirsten. And as I understand it, you're going to start construction like shortly. So this is not some futuristic development that's going to happen in 10 years in the future. This is going to happen at some point in the next several months.
That's right. Yes.
Right.
We're completely shovel ready.
That's very exciting. We did get one question already for Fiona. One before I get to the next discussion. Fiona, the attendee asked about using tall buildings and using them to store energy, and wouldn't it be closer to where the needs are, and what is the potential of that?
Yeah, no, that is a great question. And we do often get this question about, why can't you just build it above ground? And, in theory, you could. But what we're actually doing by using shafts is we can actually get much greater vertical height than is really practical to build. So we're looking at anything from sort of 300 metres to 3,000 metres in terms of mine shafts. And there are many that are extremely deep. You're never going to be able to build something economic that is that high. So if you think about it, the tallest building in the world, the Burj Khalifa, that's only 828 metres high. The Empire State Building is 440. The Eiffel Tower is 330. So you actually need to build an enormous above ground structure just in order to get that gravitational potential energy. We also see that the benefit of using existing structures, and there are many shafts globally, so it's not actually a problem of there not being enough sites. What we've found is most of the sites are grid connected. So the ones that we've actually looked at are already connected into the transmission grid. And you don't actually have to build that vertical height. So you've actually got the cost advantage of being able to leverage not only the shaft that you've got there that's already pre-built, but also all of those electrical connections and all of the reusable equipment, particularly in the mines that are transitioning. So if you think about care and maintenance or recently closed, you've got above shaft head frames that are reusable, in many cases winders and motors, substations, and distribution and transmission connections already in place. So that actually helps you then feed that back into the grid without having to invest in all of that additional infrastructure. But it is a fantastic question. Yeah,
that's great. Thank you, Fiona. Now, Kirsten, you've had a fairly interesting career in the sense that you've gone from mining and oil and gas to geothermal. Now, why geothermal, and why are you so excited about it now?
Well, it's an interesting path. Of course, when I was in university, and that's another story. I hope I get a chance to tell the story how I got into geology to begin with. But as a geologist, that it was very conventional. This is Toronto Stock Exchange listed companies exploring for conventional resources. I worked in, like I say, the conventional gold, base metals, all the things. And in fact, I was working on a coal project. And I mean, let's just full stop. I get it. Yeah, probably not the best resource choice at that point in my life. And it was a geologically frustrating project. And I was commiserating with a well-known geologist in Saskatchewan. He's known as Mr. Potash. He's involved in potash and oil and gas. He'd been working in the Western Canadian Sedimentary Basin for decades. He turned to me and he said, Kirsten, what if there was a different approach in our careers? Instead of the conventional, as geologists, we go exploring, we find it, we mine it, we burn it, and we go back for more. What if there was a resource in southern Saskatchewan where, as long as its center of the earth is hot, we have an inexhaustible supply of energy? Of course, he's talking about geothermal. And it came at a point in my life where I was very fortunate to have some experience behind me. And I thought, well, wouldn't this be a great opportunity to apply some of my tools and experience to try to develop this resource? It seemed crazy at the time. It's in the heart of the Bakken oil field. Our project is literally surrounded by pump jacks and gas flares. But the irony of that is that if that oil and gas industry didn't exist, we wouldn't know this geothermal resource existed, because to find it, we used public data in oil and gas to go exploring at first with laptop computers to determine that this resource is real. Again, I never ever would have imagined back in university that I would be in clean energy. You don't typically, in historical, you don't think of geologists and clean energy in the same sentence. And it's so exciting to now be able to take, my history and apply that to a renewable resource such as geothermal, and be, essentially, initiating a brand new Canadian industry in clean energy. And it's I'm very excited to have this project at the stage that it's at. It's been very hard also.
That's great. It was as I understand, it was an overnight success that took 13 or 14 years.
Yeah, exactly. The veil of tears.
Now, Jos, your project sounds exciting, and I don't think most people even understand the nature of a microreactor. But why is new nuclear, as you're building it now, or the SMR field, why is it a great space for young people to want to address? Or when they're thinking about career paths, why would that be a viable career path for them to look at?
Yeah, thanks, Ed. And the kind of really neat thing about our industry is there's rapid growth, and there's a couple drivers on that. One, climate change and energy security. And so when you look at the opportunities in the industry, even from a few years ago, we are in this rapid growth, and Canada is leading the way. And so when you talk at MMR, we'll be the first MMR in Canada, potentially the world. There's other utilities in Canada that will be the first SMR in the Western world. And so it's an established industry. It's Canada's leading, and there's a ton of different opportunities. And these are opportunities are from the trades to engineers to project management, accountants. It's a wide range. Every company that we deal with are hiring many people in all different areas. And I guess lastly, doing something for the first time is exciting and really, really cool. So being part of that, excites us.
That's great. Now, we actually haven't just got a question in from an attendee. What about the permitting challenges for the MMRs? And I think everybody who understands how they work would love to see one in their backyard. But how are you addressing the permitting challenges, or what are the challenges with permitting these new reactors?
Yeah, so we are in Canada are governed by the Canadian Nuclear Safety Commission, and so that's our regulator. And so there's a permitting process with a series of permits. This process is typically takes 3, 4, 5 years for a first of a kind. But part of us being able to solve this big problem is figuring out how to do that quicker. And so what we're trying to do is get chunks of the plant that'll be approved by the regulator wherever we put it, and then for the next one we look at only getting the deltas approved. And so yes, it takes time. Yes, countries that we deploy in will have to have that regulatory framework in place, but our goal is to be able to get from kind of the start to finish in the permitting back to the 2 to 3 year time range, and instead of the 4 to 5 that it is now. And when we look at the 2 to 3 year time range, that fits within some of the mining cycles that are going through similar type permits. And I guess just quickly on the Chalk River project, we've submitted our first license, which is a license to prepare site. So the first part of that's submitted. The rest of that will be submitted next year, and then we go into our license to construct and license to operate in the following years.
And how long will it take to construct, in theory, when you're fully permitted?
Yeah, so first of a kinds are always tough. So we think it'll be somewhere between 18 months to 24 months. And our goal is on the nth of a kind, or once we've done a few of these, is to get that down to a year. And when you talk about SMR or MMR, module is part of that answer. And so modules have a lot of really cool advantages where they're built in factories. They can be tested and commissioned to a certain extent in the factory. And then when you get to the construction site, you dig a big hole, and it's like Lego kind of putting it all together. So it really allows you to de-risk the actual construction part and really make the infield stuff a lot quicker.
That's great. Now, Fionna, you say that there are thousands of sites for mines around the world that are, or even just in Australia alone, that are potentially usable for your technology. How big is the actual potential for gravity storage globally, or in the context of what you're doing?
Yeah, I think the potential for gravity storage is quite significant. So as I've said, in Australia, just from a handful of sites across the potential, we've got about 13 gigawatt hours of identified capacity, if you like, potential for what we need, which is, up to 2030, we need about 45 gigawatt hours in Australia. So we're a lot smaller than everywhere else. Globally, we've identified, as I said, sort of about 285 gigawatt hours of potential to date, and that is from a handful of sites. That's from 4,000 sites. We know that there are millions, at least in the millions. So we really only need a fraction of them to be viable. And some of the really deep ones, particularly think about Canada as a fantastic location for this too. A pair of, 1,000-metre shafts could be a gigawatt hour of potential in itself. And so when you think about that, it's actually got a very significant role that it can play, but it is just one of many technologies that will actually help us get there. The challenge that we're facing here from a storage perspective is enormous. We need about 100 terawatt hours of energy storage by 2040 globally. And so there is a role to play for everything, because right now we're well under 1 terawatt hour. So think about a 400-time demand growth in storage capacity required to firm the renewables that are needed to electrify our system. So I would say that, gravity's got a role to play. It won't be the major player. There will be many other things that come into the mix as well. But I think there's a role for all of the technologies. Yeah.
That's amazing. Now, Doug, I have to admit, when I started doing research on your project, I didn't know a whole lot about geologic hydrogen. And as somebody who's looked at a lot of technology in the space, I've never been a huge fan of hydrogen projects, because to me right now the economics are strained, and it's quite a challenge to make the production of hydrogen in a fairly cost efficient way, and a lot of it will rely on a lot of government support. Now, how is your project different than the other hydrogen development projects, and what is the role of government in moving all of that forward in your mind?
Well, if we look at the other there's two other methods really to make hydrogen. One is the electrolysis of water, which everyone hears about. It's called green hydrogen. And as you say, it's got a serious challenge on cost. It also has a serious mineral challenge that we have to build all that renewable electricity to do this electrolysis, which ends up becoming very inefficient overall. And then you have so-called blue hydrogen, which is conventional hydrogen with carbon capture and storage, and also faces a lot of issues. Really the advantage of geologic hydrogen, well, first of all, it's interesting because no one looked for it in the past. It's one of those things that no one really paid attention to. So I hear there's good discussion about geothermal energy, and I'm sure if she tests her wells, she'll find lots of hydrogen coming up along with her generated fluids. And people just don't look for it. But there are places on Earth that you can drill down 100 meters and find 98% pure hydrogen accumulated down there, and not just a small amount, but millions of tons of geologic hydrogen readily accessible. The expectation is, it's going to be the extraction process is similar to natural gas. You drill down to the potential source of it, and stimulate its production. The expectations of those now in the industry is it could be in the range, the cost is going to be far below that of green hydrogen. So it's really going to make the economy possible. And the thing that excites me about it is it actually is forming everywhere on Earth. And so if we can figure out how to stimulate it and engineer the subsurface to get it out, we can find hydrogen everywhere. So that really changes the paradigm of how we use it for this. And to give you an idea of the size, the chemical potential for hydrogen just in the United States, so if we look at the ground beneath us and say, what's the chemical potential for forming hydrogen? It's 146 trillion tons of potential under our feet. 1 billion tons would power the US economy for a year, everything. So it's the potential is much greater than oil and gas.
That's amazing. I'm trying to do the math on how many years in thousands of years of potential hydrogen just from the United States alone to power your own needs, which is quite amazing. And you've funded your first project, am I correct?
Well, we're funding our first projects in the area right now. We are the ARPA-E is the first governmental agency in the world to launch funding on this. And I think we're not going to be the last governmental agency. There's got to be a lot of interest in this. And the video I tried to show was from a meeting in Oman on the Arabian Peninsula, where we have now a bilateral agreement with Oman to develop materials. I'll be in Australia later this month for discussions with people about how do we collaborate with the Australians on this. Because and this is one of those big things, if it works, it's almost a limitless supply of clean energy. And it's Mother Nature has been forming it. We just kind of overlooked it.
That's amazing. Now, Kirsten, there were a couple of technical questions that came up, and I don't know how much you can talk about it. Now that your project, you said when we spoke, as 30 megawatt is your first project. Somebody asked what kind of capital is needed to build a project like that, and the other question on the project was what are you doing to deal with corrosion mitigation in the project?
Yeah, great questions. In light of the time in this session, I'll try to be brief. We've spent about $65 million to date to ensure that we've successfully drilled out this resource. I like to say it's very important in geothermal that we know what the resource can do, but even more importantly, to know what it cannot do. And so it was very important for us to make sure that we tested the resource properly. Very proud to announce 3 weeks ago that Schlumberger, who has a boutique company called Geothermics, is the global standard for geothermal resource assessment, has provided us with a third-party review supporting our project will last for 40 years of power generation. It was a pretty emotional day for everyone on the team. It's something that we've been working for years. It's been expensive. Geothermal is expensive. We don't shy about that. It's not like wind and solar where you can put up monitoring devices and, over the course of a year, know exactly what your resource is. We have to drill expensive, deep wells, test them, and do extensive reservoir modeling. I saw there was a question about corrosion.
Yes.
If you're at this conference here today, it's one of the number one topics. You can't talk about geothermal without talking about corrosion. It's not water that we're bringing up. We're bringing up brine. In our case, it's 10 times saltier than seawater. You pick up a bucket of it, it's not just water. It's heavy. So there's lots of strategies as far as corrosion inhibitor that's pumped into the wells. In our case, our brine is nasty enough that we're actually going to put a polymer coated tubing string inside our well to protect the casing. Just in light of time here, I just want to tell a quick story. I'm not sure if we're going to go through the agenda quickly, but I wanted to have the opportunity to as Jos did, to share some advice with the young people. I think, what Josh mentioned earlier is, don't be afraid of making mistakes. Don't be afraid of jumping into where you're maybe a little bit uncomfortable. When I started university, I went into business administration. I didn't even know what that was, but my friends were going into business administration. I'm like, well, I want to do what they're doing. We can go to the classes together. It'll be fun. I flunked out, completely flunked out. I had a good time. There was lots of parties, but totally flunked out. Went back to my hometown of Estevan, Saskatchewan, and waitressed in a bar. And it was interesting because in Estevan, it's oil and gas country. It's power generation. And it was the first time that when I could see the clients, that this was an energy town. I never noticed this stuff when you're in high school. I took a night class in geology, and all of a sudden I realized, hey, I like science. In fact, I like geology. And hey, there might even be a job at the end of the day. So, I ended up going back to school, I fell in love with my courses. I fell in love with the people around me, my fellow students. They're friends of mine today. It's part of that culture. I think that is really important as a student to jump in, say hello to the people next to you in your class, go for coffee, make those bonds, because that support system in university, finding your passions is really important, because guess what? It's okay if you don't know what you're doing. You're gonna figure it out, especially if you're brave enough to jump in and expose yourself to lots of different opportunities and lots of different things that maybe you didn't know about. And sometimes it's just through conversations with others around you. It's you'll find a project that I like to say it's a Venn diagram, like the circles, and you'll find a career eventually where it's a circle of passion, circle of opportunity, and of course a circle of getting compensated for that as well. And you'll find where those intersect is where you'll really have a fantastic future life path.
And that's great, Kirsten. And you must be a little bit psychic as well, because that was my last question. I'm going to give everybody a minute to talk about where, what would you say to your 18-year-old self going into the world right now, if you could give yourself some advice? And I'll give each of you a minute, and I'll start with Jos.
Well, I think I kind of already touched on that. Is yeah, don't be afraid to fail and go after things that are difficult. And as long as you're learning, it's not a failure, it's a success in the end. That's great. And Fionna?
Yeah, I'd say, I think the other part of it is, pursue your passion. So you want to do something that you love. And it doesn't really matter if you're not quite sure where the dots connect. If you're doing something that you'll love, if you're doing something you love, you'll put your best into it and you'll get the most out of it. And your path may not be that direct, but you'll look back on it sort of 20 years from now and say, well, I learned something amazing from that experience and this one, and all the dots will shape into something that, you've found yourself in. There's been many experiences on your journey that have led you to where you are. And probably the other thing that I would say is, and this is probably a little bit more future focused, is this is actually just an amazing time to be involved in this space. And you've actually got the runway ahead of you to make a real difference to, the footprint that we leave on this earth. And so that's actually just another really exciting thing to say, embrace the opportunities, because going forward, we just need really smart thinkers who can look at things differently and see the world in different ways, because we need new ideas to take us forward and really kind of change how we're living here. Yeah.
That's amazing. And from the final word from the idea creating lab himself, Doug, what do you give advice to your younger self, or why are you optimistic about what's going on in the world?
Oh, why am I optimistic? I'm optimistic about a lot of things. But I'd have to say what I would tell my 18-year-old self is view your life as a journey of learning. When you're in school, it's like you got to get to the end of the semester, or you got to get to the end of the quarter. And then you're like, I'm going to get my degree, and then life is going to be, set. It's actually just prepare yourself for lifelong learning and growing. When you get out into this world, things don't end at the semester anymore. Now it becomes a continuum of how you're going to grow and realize your potential. And have, and I also tell myself, I was a very insecure 18-year-old, is have confidence. It's, you've got to look at the people in front of you. They had the same problems you did. And it's just having the confidence that you can get through it. Today's issues will do it, but you really have to, again, come back and emphasize you have to learn on a long-term basis. It's quite exciting.
That's amazing. Thank you, Doug. And putting back in the context of my journey, I'm my age, and I just finished another degree, and I'm still searching about where I want to be in life. So that's amazingly poignant what you just said as well.
Yeah.
We have 2 seconds
Hopefully
left.
I'll figure out what I want to be when I grow up.
One day. Well, we're at the end of our session. Thank you so much for everybody's participation, and I really appreciate everyone spending your time with us today. And if anyone else has any questions, we'd be happy to probably answer them offline later if there are any other additional additional questions. Thanks, everybody.